Before I start this video, let me take 30 seconds to tell you something about Exergic. Exergic is India's most trusted and most experienced institute for online GATE preparation. I am Chandresh Mahajan, founder and chief educator at Exergic. I am an All India rank 37 in GATE Mechanical Engineering, an ex-Indian Oil officer having 7+ years of teaching experience as of now. To know more about our GATE courses, you can visit our website or contact us on these details. Also, you can download Exergic GATE Preparation app from Google Play Store. The link is available in the description of video. Now have a look at this question, where a thin-walled cylindrical container with 2-meter diameter and 18 mm thickness is open at the top. In this case, again you have a thin-walled cylindrical container. Thin-walled, you can see also radius is quite high as compared to thickness, and it is cylindrical in shape, and it is a container. Again, container means hollow. Again, a hint that it's a question from thin pressure vessels, right? Containers are made to contain something, to put something into. So they are hollow. It is open at the top. So this is an interesting variation. Generally, the questions of pressure vessels that we solved, they are totally closed, right? Everywhere. Obviously, sphere is entirely closed, but even the cylinders that we deal with are closed everywhere, from top also at the bottom. And such vessels are used to contain liquid also, to contain gas also. But if I have a cylinder which is open at the top, from here it is open, clearly it cannot be used as a pressure vessel for gases, because for gases you need it to be totally closed, otherwise gases will escape. But it can definitely be used as a pressure vessel for liquid, and that too in this configuration. You cannot have an open cylinder like this and you can use that to store a liquid, because if you pour the liquid into such an open cylinder, maybe it is open from one side, maybe from the both. Let's even consider this closed, even then it will fall down, right or not? So open cylinders from one end or from both the ends cannot be used to store gases, unless and until you have some external support. This is also one more important point. You can use hollow cylinders to store gases if you have some external support. For example, if this is a cylinder, hollow and open from both the sides, but I choose to put some wall on this side also, which is covering one end, totally closing one end, and from this side also, which again is closing and covering the other end, right? So if I put up two walls, two sections, absolutely in contact, totally in contact with these surfaces, now whether it is horizontal, whether it is vertical, it can be used to store anything, because now it is as good as a closed, completely closed vessel only, because rather than having a capping directly put on the cylinder, you are using some external agent to close it. That's the only difference, right? So this again, an open cylinder from both the ends also can be used to store gas if you are externally closing it, and closing of end is not inherent part of the cylinder. Externally some wall, some setup you are using to close it. Got it? So don't do this mistake. That question gave you open cylinder and just you have this idea in your mind that, oh, it is open, that it cannot be used. It's not like that. External things can be used to prevent it. Rather, you will be seeing the concept that I am discussing, you will be seeing questions on those concepts in GATE also. These are the very interesting variations in case of cylindrical or pressure vessels, where GATE continuously asks questions. So if you have such a setup and suppose it is open from one end, this is as good as a closed one, so forget about this. But suppose if you have one end closed, maybe externally or maybe inherently you have a cap there, so that cannot be used, this is closed, to store liquid if it is horizontal, right? So if it is open from any one end, it has to be vertical. Only then you can store liquid, otherwise liquid is going to fall out, right? This is first thing that you need to understand in such questions, okay? The height of the water, as you can see, it is vertical. You can get the idea from this word. The height of the water in the tank. So obviously it's going to fill like this, right? And consider one more point here, which was, again, this diagram was given to you in the question. I removed that. It is placed on a surface. It's important. You will realize why it is important, that it is resting on a surface and not hanging from somewhere. So height of the water, you are pouring it in water into this. So height H of the water, weight density of the water is also given to you. Weight density, kilonewton per meter cube. So height of the water in the tank at which circumferential stress reaches 10 megapascal in the tank wall is approximately how many meters? If this is empty, we are not considering weight of the tank, so no stress, right? But when you start pouring water, you need to see here what type of stresses will act, whether circumferential stress will even act or not. Then you need to do the calculations accordingly. So from here, the interesting part, even more interesting part starts. Discussion gets more interesting. So let us consider one stress element on the wall, right, of this specific container. Assume this diagram is given to you, it is resting on a surface. If you have filled in a fluid into this container, this is the fluid that we have filled in. Obviously, fluid always exert pressure perpendicular to all the walls, all the surfaces that it contacts, whether it is the bottom surface or whether it is the side surface. So it is pushing the side surface from all the sides, right? This is a two-dimensional diagram. These two lines only I am showing you. But it is going to touch all the vertical walls, the curved circular vertical walls, lateral surface. Every part it will try to push. So if in such a situation, if on a circumference, a force is being applied, which is always acting perpendicular to that, which is trying to push that away. So what will happen? It is trying to extend the radius, it is trying to expand the circumference. What will happen? Circumferential stress will come into the action. It will try to bring it back to its shape. So here, if fluid is present, it is going to exert pressure perpendicular to curved surface that is trying to expand the circumference. So circumferential stresses or hoop stresses will be coming. Point number 1, whether it is open, whether it is not open. Point number 2, will those values of circumferential stresses be same? That we need to see, because in the expression of circumferential stress, it is going to be proportional to pressure, right? And is the pressure value same at this point, at this point, at this point, here? Is that value same everywhere? Pressure? No. Whenever you get a question of pressure vessel, I will highly recommend you that if it is a direct question, no issue. You have to be careful about radius and all the things that I have taught you. But if you get slightly different question, be very, very careful about the orientation, whether it is vertical or horizontal. You will see why. You will see that. As I discuss it more, you will realize that. Be careful whether it is resting, whether it is hanging. Again, that will be more clear to you when we discuss it. Be very careful to see whether it is a gas or a liquid. Because if it is a gas, pressure P will remain same everywhere, right? Because the variation of pressure with the depth is very less for the case of gases, because delta P you can say is equal to rho GH. Since rho value is density is very less for gases, for small values of height change, like the cases that we are going to deal with, 1 meter, 2 meter, 10 meter, 50 meter, 100 meter, that change is not going to be very significant, right? Because density value is very less. That is why delta P value, if this was maybe a closed cylinder totally filled with gas, vertical also, then delta P value will not change much within the gas, within the tank. So that's why P value we took everywhere, whether we are considering circumferential stress, this point, this point, this point, any point we consider, P value we take as same. Even for the fluids, you will see that in some questions, they will ask you to take single value for P. Again, for that case, maybe height difference is not much, maybe pressure difference is not much. Very rare questions. But generally, if question has specifically given you such thing, open, tank is open, obviously something is there to pay attention. Specific orientation is given to you, right? Again, second point which you should be careful about. Then obviously you should be careful about whether it is liquid or not, and if it is liquid, density is not as less as the gas. Density changes, pressure changes with the depth because density is a descent number, and hence change of pressure occurs with the change of altitude. That is why pressure, you cannot say that I will apply PD by 4T, PD by 2T, PD by 8T, whatever different expressions we have covered everywhere. You cannot do that because pressure will keep on changing. You need to use that specific value of pressure. Getting the point? So in this situation here, pressure value is changing. Here, pressure is atmospheric, right? If I want to write that in terms of gauge values, then rather pressure is 0 here. And we know that pressure increases linearly, right? P is equal to rho GH. So pressure value will keep on increasing as we go down. So stress value, circumferential stress value is also going to increase linearly because in the expression of sigma, sigma is directly proportional to P as we know. So linearly it will increase. Whenever you have such variation of stress or pressure, which point or which section are we interested in? Critical section. It can be a point, it can be an area, it can be some section. And how do we decide critical values? Throughout the strength of materials we have done that. Based upon that point, that part, that section, that cross section which is heaviest loaded, highly loaded, most pressure, most stress, right? Here, which is that section? The bottommost cross section, this one. Because at this section you can see the pressure value is extreme, right? So you can consider that to be a section, bottommost section, or you can just be interested, in a single point, this point only, because all of the points on the bottom section are on the same level. All the points will have same pressure value, so same stress value when we are talking about circumferential. Obviously, when we talk about circumferential, for this case, only circumferential points are going to be of interest, right or not? Although pressure will be same, if you consider the base also pressure will be same, but since we are talking about circumferential stress, we are only looking at circumferential points. Obviously, all of them have same pressure, same elevation level, same depth. So pressure value will be same for all of them, which will be highest anywhere as compared to other points, right or not? So this is how you first need to realize that yes, circumferential stress will act, and circumferential stress will keep on changing, will rather keep on increasing with the depth, with the pressure. How? Linearly, because pressure is increasing linearly and sigma and P are directly proportional to each other in the expression of stress, circumferential stress. Clear up to this point? In this case, it has given you that in the tank in which circumferential stress reaches 10 megapascal, it has given you a value of circumferential stress which should not cross. Obviously, it is giving you the value which should not cross at this point, because if it is not crossing 10 megapascal at this point, it will not cross 10 megapascal at all the other points, because at all the other points pressure is less, right? And if it crosses 10 here, it may not cross 10 at other points, but definitely it has crossed 10 here, right? So you need to make sure that this point stays not more than 10. It will automatically ensure every point is below 10. If you think, no, I will load each and every point up to 10, that is not possible because it's a linear variation. If you want to take this stress up to 10, then obviously the other value of stress at the bottom point will increase even more, which will cross 10, right? So whenever in such cases single value is given, it should not cross 10. You have to use your sense. Critical section, you have to use. Critical section is not something new that we are discussing for the first time. Throughout different subjects, we have discussed, throughout different units of strength of materials, we have discussed that. Whether axial loading, whether torsion and all, right? So now you need to use the expression of circumferential stress where allowed value is this much. How much is the value of pressure at the bottom point, that you can calculate by using the fluid mechanics concept, right? And then you can move further and do the calculation. Now, for some of you who may not, because practically speaking, fluid mechanics should be covered after strength of materials, because in fluid mechanics we talk about stresses, strains, even angular deformations. We draw this element, stress element, right? So all these things will go above your head, or even if you somehow understood, it will be half knowledge. You will not be able to take full feel and knowledge if you have not covered strength of materials first. So maybe some of you who are starting strength of material first don't know any concept of fluid mechanics. It's good, not an issue. But P is equal to rho GH is something that we discuss a lot in school, right? So I expect that these questions, at least P is equal to rho GH type, you can understand and solve, right? Don't worry, this discussion will be done from zero level in fluid mechanics again. Don't think that I am telling that you should know this from school and I will not tell you. Each and everything I will tell you in fluid mechanics from the very basics of a single fluid particle, where we will be again coming to this expression, talking about this, understanding its significance. But just in case, if you recall, it will be good for you, because gate you are not going to write now only after finishing SOM. You are not going to go and write gate. You will write gate when you have covered both. So if this question comes, obviously you will be knowing everything. So you will be in a state to answer the question. As I told you, in this case, we know all the values. Just put the values. Let's get to the answer. So this is the expression that we know for circumferential stress in cylinder. Here P, as I told you, can be written as rho GH, where H is the depth from the free surface, from the surface which is exposed to atmosphere. Rho G value is known to you, weight density. Again, a concept that will be discussed in the first unit of fluid mechanics. Rho G is weight density. That value is given to you, and H is required, obviously. Let's put the values. Sigma C value 10 megapascal. I have converted that to Pascal, because if you see in the question, you need answer in meter, right? You need the answer in meter. So it's better to keep everything in Newton and meter. So megapascal needs to be converted to Pascal. So 10 multiplied by 10 raised to power 6 Pascal. Rho G value is 9.81 kilonewton. So I need to convert that to Newton by multiplying 1000. Meter is fine. H we want to find out. Diameter is 2 meters divided by 2t. T is 18 mm divided by 1000 to convert into meter. H is the only unknown. Solve, and this is the value of H that you are going to get. If this question was asked as an option, maybe, because in such cases where you have been mentioned approximately, then generally such questions are asked as MCQ question, where you will be given 4 options. One may be 10 meter, 12 meter, 14 meter, 18 meter. So 18 will become the answer. If you have been, in NET question, you won't be said approximately, right? You will be given rather up to how many decimal places you need to answer. It can ask you to round off to nearest integer, which again will give you the answer as 18, or it can ask you to round off to 1 decimal, 2 decimal, 3 decimal, okay? Now, as I told you, that if we are filling a liquid in a cylinder like this cylinder is open from the top and it is resting on a surface. This is one case. And other case is that the same cylinder, rather than keeping it on a surface, we have fixed it. Some of you may think that, okay sir, now it has been closed. But please note, it is not yet fully filled. Even if it is closed at both the ends, it is used to store a liquid where pressure is varying, and that too not completely filled. So you can see that there are still 1-2 variations in this case which is possible. And let me tell you, the case when we are placing it on a surface or when we are hanging it, that is going to change our answer and our analysis. This is the another point and another variations that we have to now discuss in the next question.